Welcome to video 5.4, the performance characteristics of the C#7 tuple feature. In the previous video, we discussed about the ref return C#7 feature and we saw its positive effect on value types. In this video, we continue our journey through value types. Here we will talk about value tuples. First, we will discuss what C#7 tuples are, and we will also compare it to the classic system.tuple type that already existed before C#7. Then we will look behind the scenes to understand the implementation of value types, and as always, we will focus on the performance aspect of this feature. Now, one thing I would like to mention is that our goal here is not to understand every tiny detail of the tuple syntax in C#7. Our focus is to understand the performance implications. So let's start with the basic syntax. On this slide, we have a method which basically returns two values, the minimum and the maximum of the input parameter, which is a list. Now, if you haven't seen C#7 yet, you may wonder if this compiles at all. Fortunately, this compiles. This is absolutely valid C#7 code. This method returns a tuple which contains two integers. Of course, you are not limited to two values. You can return as many as you want. Before C#7, you either created a type to store the two integer values, or you could also use out parameters. Another option was to use system.tuple, which we will talk about soon. But in C#7, you can use this syntax to return multiple values from a method. And here is how you can call such a method. As you can see, in the caller method, we can use the min and the max names that we defined in the signature of the getMinMax method. This is very nice compared to the classic tuple type, where you only had item 1, item 2 and similar properties, which is a potential source of programming errors, since on the caller side you don't really know what those values store. You can also decompose a tuple, and there are other nice syntactical additions to it, but for us this is enough to start the discussion about the performance characteristics of this language feature. I mentioned system.tuple or classic tuples before. If you are not familiar with that, here is a quick recap. The system.tuple type was introduced in .NET 4.0. On this slide, you can see the implementation of the getMinMax method with system.tuple. This also compiles in older C# versions. Interestingly, what we saw before with the C#7 syntax has nothing to do with this system.tuple. The idea is of course the same. In both cases, the tuple is a data structure that has a specific number and sequence of elements, but the implementation of the C#7 tuple feature doesn't use system.tuple. Well, then the obvious question is, how does that work? In this demo, we will look behind the scenes of this feature. So I have the two sample methods here in Visual Studio, one with system.tuple and the other one with the C#7 tuple. Let's compile this and look at it in dnSpy. This is the system.tuple method. Nothing special here. The method just returns an instance of the system.tuple generic type with two integer parameters. So this is exactly what we expected. Let's see the other method. As you can see, the return type of this method is system.valueTuple, so not system.tuple that we had in the previous method. So this is the underlying type that powers the C#7 tuple feature. This feature is often called value tuple, which I guess comes from the name of this type. This type was added to the base library recently, so in earlier Visual Studio and .NET versions you had to add a NuGet package when you wanted to use this C# feature. The NuGet package contained exactly this type. Now, why wasn't the system.tuple type just reused? What's the difference between system.tuple and system.valueTuple? The biggest difference is that system.tuple is a value type. If we look at it, we immediately see that it derives from system.valueType, so these two have different performance characteristics. System.tuple will be allocated on the heap, so the getMinMax _ system_tuple method always allocates a system.tuple instance on the heap, and that also has to be cleaned up by the GC. On the other hand, when you use the C#7 tuple feature, there won't be any allocation, so that uses stack-based memory. Another interesting thing is that the items on value types are stored in public fields. So what we have here is a mutable value type with public fields. Now this is something that which according to some design guidelines you actually should never do, but of course the C# language designers thought about this, and in this particular case I guess this seemed to be the best solution. So let's measure this. We have here two methods which call these two different implementations, each 1 million times. I already have the benchmark.net results here, and as you probably expected, the GC has much more work to do when we use the classic system.tuple type. In case of the C#7 feature, the GC didn't do anything, only the list was allocated and GC'd, but that's it. Let's summarize what we learned in this video. So the new C#7 tuples feature is based on system.valueTuple, which is a value type. In contrast, the system.tuple type, which was introduced way back in .NET 4.0, is a reference type. So this means when you use the new C#7 syntax, then you reduce the work the GC has to do, since the method returns a value type on the stack. It's also interesting that this feature is actually a combination of some syntax improvement in the C# language itself and a new type. And I repeat my advice again, all this only matters in terms of performance when this is used in a tight loop. I think the C#7 tuple features has a very nice syntax. It's definitely good to use it in new code, but if you have an existing code base where you use system.tuple as return type in multiple methods and the code performs fine, then don't rewrite the code just because of this feature. On the other hand, if you see that the GC became the bottleneck in your code, then you can definitely try to use C#7 tuples, but remember, always measure it. Thanks for watching. In the next video, we will discuss how you can optimize async methods with value task.